I'm Anil Kumar. Let me thank all my subscribers for taking interest in my channel and posting excellent questions. Here is one of the questions received. It was written in short, so I wasn't very clear what you're looking for. So what I did was that I kind of have two versions of your questions. So let's see if it meets your requirements. The question has been now modified as, the first one is, Anna runs along a 100-meter circular track and completes 4 laps in 8 minutes. Her purse is 1 meter away from the starting point on the baseline as shown. So this is the baseline and that's the track, circular track. Model Anna's shortest distance from the baseline with distance run. So with distance run by Anna. So that is one version. So I wasn't sure whether you want to model with respect to distance or with time, right? So I made two versions. The second one here is, Anna runs along a 100-meter circular track and completes 4 laps in 8 minutes. Her purse is 1 meter away from starting point on the baseline as shown. Model Anna's shortest distance with time from the baseline. So I hope you appreciate the difference in the two questions. One, for the same situation, is with respect to time. The other one is with respect to distance, right? So we'll do both of them and I hope it works for you. And track also, I made it circular so that we are clear what we're talking about. And distance, which we are interested in finding, is vertical distance. So I've extended this baseline as shown here. Perfect. So let's say that's the center of our circular track. And here we have a purse. And this is the baseline. So what I will do, I'll first create my axis. So I prefer to keep 0 where the purse is. That becomes the baseline. Okay. So in this case, we are doing with time, so that becomes time for us. In the next example, I will take distance along the independent axis, right? The vertical axis will give me vertical distance. That is to say, if we are at that position, so the vertical distance is this much, which is radius plus 1 meter. Is it okay? And as she runs along the track, the distance, we are always measuring the vertical distance. Remember that part, correct? We are not measuring distance from the purse. That would be very difficult at this stage. So we are not going there. Okay, easy things first. Fine. So let's trace the path which gives you height with time. So this is the axis, right? Let's make this line also. Take your time in sketching. While you sketch, think about the solution. That's the strategy. Perfect. Maximum distance could only be this much. So that is one extreme. So sometimes we also talk about domain and range. So in the range, we have to mention minimum and maximum distance, correct? So this becomes the minimum distance. Correct. How much should this be? Well, we could find from the circumference. So we know this is a circle. That means pi d, where d is the diameter, should be equal to 100, right? So diameter should be 100 divided by pi. That is how much? Let's calculate. 100 divided by 3.14, okay. In decimals, 31.8, so it gives me 31.84 something. I'll round it to 32. Is it okay? We'll do whole numbers. Perfect. Now if diameter is 32, radius will be how much? Radius will be half of this much, right? So radius will be diameter divided by 2, which is 32 divided by 2, which is 16. And all units are in meters. So we got some distance now. So if I assume this to be my axis, so 0 is right there, that should be 1, and I have diameter of 32, so the maximum will be 1 more than 32, perfect, 33, and that is 1 more than 16, the radius, so that is 17. Do you see how I get? So from the purse position, which I am using as origin, track is 1 meter away, then the radius is 16, so 16 plus 1, 17, another 16 takes you to the maximum distance away from the purse. We're talking about vertical distance, right? Remember that. Okay. Now, let's trace the path. And we are assuming she's running in counterclockwise. So most of the trigonometric functions, that is considered to be positive. So we'll assume that. So the path could be kind of like this and then like this. Is it okay? Time is along the independent axis, and so, kind of like this. Let's go. So this is time, t. She can run 4 laps in 8 minutes. So we could have minutes, but we could have seconds also, right? We could have minutes or seconds. It doesn't matter. Let's find the time period. Okay, so it's a good time to find time period. So what we are given here is, we are given 4 laps in 8 minutes. So 1 lap in A divided by 2, which is 4 minutes. I'm sorry, 1 lap is A divided by 4, which is 2 minutes. Perfect. So you could have a time period in minutes also, no problems, or you could have it in seconds also. So if you want to make it in minutes, you can keep this in minutes. Time period will be 2 minutes, but I'll prefer to put it in seconds. So we'll say time period is 2 times 60 seconds. Is it okay? Which for us will be 120 seconds. When time period is 120 seconds, what is the value of k? Now what is k? Okay. We'll like to model this with the help of, since it starts with a maximum or a minimum, cosine is a good function. So we'll say height, or you can say distance. Okay, distance with time is equals to amplitude times cos of k, and this is t here, minus some phase shift. So let's call this as p plus q. So k is this. So k is defined as, since one full circle is 360 degrees, one full circle, let's say one full circle is 360 degrees, so we'll have k as 360 degrees by time taken. Time we're taking as 120, working in seconds. So that gives us 3. So k value is 3. So we know k now. What is A? A is the amplitude. A is how far away you are from the axis itself. So this is A for us. Is it okay? Now this distance is the radius, which is 16, correct? You're 16 away, that is the radius. So this is 16, and also this distance is also 16, right? So we know A is 16. Okay. K is known, A is known. What is Q? Q is the axis. So axis is 17 away. So we can now place all these values one by one. We know A is equals to 16. How far you are from this axis? Where is the axis? Q. X is 17 away, right? So we got this. K, we already calculated this as 3. How about the phase shift? If I consider that to be cosine function, I could treat this as 180 degrees, right? Or I could use minus cosine. So I'll prefer that. Is it okay? So with that, we can write down the equation as distance t equals to value of a rounded to whole numbers, which is radius, is 16, but I'm writing negative since it starts with minimum, not maximum. 16 cos of k is 3 for us, right? K3 time t plus q, which is 17, right? So in this particular case, that becomes the equation. Is that clear? I hope the method is also clear. If you have doubts, you should definitely post. So that's, now let's take the other variation of the same thing. So this is right here. So with the first part, I think the concept is clear. What we are really talking about is Anna runs along a 100-meter circular track and completes 4 laps in 8 minutes. Her purse is 1 meter away from the starting point on the baseline as shown. Model Anna's shortest distance from baseline with distance run. So that's a variation. Okay. So let's begin as we did earlier. That's the baseline. We'll keep that as time. No time. This time it is going to be distance, right? Okay. So we are saying distance run. So D in meters is going to be along the independent axis this time. That is a variation. It's a huge change. You will soon appreciate. And that is the distance away. I don't want to keep 2 D's. So I'll make this time a height function. Is it okay? So height. So vertical we are talking about. Perfect. We already calculated that when 100 meters is the circumference, so we say 2 pi r equals to 100. That means r is 100 by 2 pi. And we rounded this answer to, let's do it again. 100 divided by 2. Then we divide by 3.14 equals to, and we round this to 15.9, round it to 16. So we round this to 16, correct? The purse is at this position. Let's call this position this time as P. Okay. And it is 1 unit away. So this is 1 for us. Plus 16 gives us 17. Plus 16 more gives us 33. The path followed will be kind of like this. Let's use this color. As we did last time, we'll draw the axis, maximum minimum value. It really helps to sketch the sine function very easily and accurately. So even this rough sketch which I am doing is fairly accurate for your test purpose. Remember that part. So the movement is kind of like this, okay, and then it goes like this. So I'm just drawing a wave, one wave, okay, one cycle. Okay, let's go like this. So we have something like this. Perfect, good job. Now the idea is, what is the one cycle now? Since we are talking about distance run, when will Anna return back to starting point? That is what one cycle is. Clearly, after running 100 meters. After running 100 meters. So this will be 100. Do you understand? Distance for one full cycle is going to be 100. That is what is very important. Correct? So we are not talking about time now. How much time she takes to run. We are talking about how much distance she runs, and then we'll try to figure out the height. So that is how this question is very different from what we did earlier. Perfect? Okay. So really speaking, time period for us now is T, which we call time period, is actually when will it repeat. So period of this cycle, it repeats after every 100 meters. So that becomes T for us. It repeats after every 100 meters. Correct? So that is going to be the time period for us. And therefore, when we talk about K, so we are still working with a similar equation. So let me write down the equation first. Since we are starting with a negative point, so we'll say height with respect to distance d is equals to minus cos k times d, this distance, plus the axis. So let's put this still as q, right? Plus the axis, and we know some amplitude. Let me write capital A this time, amplitude. The value of amplitude A is still the same. That is distance away from the axis. Is it okay? Distance away from the axis. So the value of A is equal to 16 for us. Q is still the same, which is how far from the baseline that axis is. It is 17. So Q is also same. How about K? Now earlier we were talking about time, and therefore 2 minutes which she took for running the whole path was time period. Now it is 100. So K is going to be equal to, this implies K will be equal to 360 degrees divided by 100. Do you get the idea? That is what K is going to be, right? So substituting these values, let's simplify this. And let's keep fractions, right? Let's keep fractions. There's no point rounding this to whole numbers, okay? Otherwise you'll get very wrong results. So we're working in degrees. 360 degrees divided by 100. So you could divide by 2 and write this as k equals to, let me write down here, k equals to dividing by 2, 18 over 5. Is it okay? 18 over 5. So the height function can be given as minus amplitude is 16 cos of 18 over 5 d plus 17. Do you see that? So that is how we could model the given situation. I hope the concept is clear. These examples we could do with respect to time or with respect to distance. You will come across similar questions when the example could be a car picked up a nail and find the height of the nail from the ground as the car moves with a speed of 100 kilometers per hour. Now the question could be, find height of the nail with respect to distance covered, or it could be with respect to time, right? What will be the height of the nail after an hour, or it could be what will be the height of the nail after the car runs 5 kilometers. So that makes a huge difference. I hope that concept is clear. Feel free to make suggestions, subscribe, and share your views. Thank you and all the best.